Hello everyone, welcome to my class. Today we are going to discuss some more concepts on machine. So without wasting time, let's start the class. Okay? Students, today we begin the class with a discussion of levers. What are levers? Levers are the simplest form of machines which we use in our day-to-day life. And how can we define lever? It is a rigid, straight or bent bar. You need to remember it can be straight or bent, which is capable of turning about a fixed axis. In a lever, the bar can be straight or bent, but it moves around a fixed axis. And the axis about which the lever turns passes through a fixed point which is called fulcrum. And it is denoted by capital F. Students, let us now discuss about the principle of a lever, or we can call it as mechanical advantage of a lever. Okay, mechanical advantage of a lever. So to discuss about the mechanical advantage of lever, let me first draw the diagram of a lever. There are three types of lever actually, but I am going to draw the diagram of the class 1 lever. We will discuss about all the types of levers afterwards. Okay, to discuss about the mechanical advantage, I am going to draw the diagram of a class 1 lever. As we have discussed that lever moves around, or it moves about a fixed point, that is called a fulcrum. Suppose this is the fulcrum at the center of the lever. Okay, and here we have effort and here we have the load. Okay, effort and load. This is our fulcrum which is represented by F. So the lever, this is the bar which moves about this fixed point. Okay, moves about this fixed point. So if I name these points as A and B, so you can see that there are two distances. One is FA and another is FB. Okay, so the distance of effort from the fulcrum is FA and distance of load from the fulcrum is FB. Fine. So these distances are named as FA. It is called our effort arm. Effort arm. And FB, load arm. Distance of effort from fulcrum is called effort arm. Distance of load from fulcrum is called load arm. So these are the terms related to a lever. And as we have already discussed, for idle lever, it is assumed that the rod is weightless and there is no friction in this lever. Okay, because friction opposes motion and it is not an ideal lever then, so there is no friction and the rod is now weightless. Okay, students, lever works on the principle of moments. In the equilibrium position of lever, moment of load about the fulcrum must be equal to the moment of effort about the fulcrum, and the two moments must always be in opposite directions. What does moment mean? Moment is nothing but product of a distance and a physical quantity. So what are the distances over here? See, FA is your effort arm. This is effort arm. And this is load arm. So, moment of force. And what are the direction actually? Here, the moment of load is acting in the clockwise direction and moment of effort acting in the anti-clockwise direction. So we can say that clockwise moment of load is equal to anti-clockwise moment of effort. Moment of load means distance into physical quantity. So it is distance means load arm. Load into load arm. is equal to effort into effort arm. That means L into FB is equal to E into FA. Okay, that implies L divided by E is equal to FA divided by FB. And what is L divided by E? We have discussed in the earlier classes that mechanical advantage is the ratio of load to effort. So we can say that as L by E is the mechanical advantage of a lever. So if we substitute L by E with MA, so mechanical advantage of the lever can also be the ratio of effort arm to load arm. Okay, so MA is equal, that is effort arm to load arm. So this relation is known as the law of levers. Okay, so mechanical advantage of a lever is the ratio of effort arm to load arm. Okay, this is the law of levers. So students, from our discussion till now, we come to the conclusion that the mechanical advantage of a lever is equal to the ratio of the length of the effort arm to the length of its load arm. So mechanical advantage is equal to effort arm by load arm. So from this equation we can clearly say that when effort arm is equal to load arm, mechanical advantage would be equal to 1. When effort arm is greater than load arm, mechanical advantage would be greater than 1. And when effort arm is less than load arm, mechanical advantage would be less than 1. Okay, you need to remember this. Students, today we have discussed some concepts on machine. I hope you have understood everything clearly. If not, please take the book with you, go through the book and watch the video again. I hope you would understand everything clearly. Okay, so for better understanding, I always say that keep revising, keep practicing, and most importantly, keep smiling.